Hi everyone, I want to present my project to you. Automated analysis and detection of optimal number of buses on the route depending on hours and type of day. Transportation system always is the one of top hot topics to discuss in Ukraine, especially in big cities. The relevance of the topic can be explained by huge arguments between bus drivers, population, and government. The problem is discrepancy between the number of buses and the number of passengers, and it depends on which part of day it is. Research of the topic involves queuing theory, operations research, statistical analysis, and also methods of machine learning. Queuing theory is a subject to which many books have been devoted. It ranges from the study of simple single-server systems modeled as birth-death chains to the analysis of arbitrarily complex networks of queues. The relevance of the topic can be explained by huge arguments between bus drivers, population, and government. The first one say that very little number of people use buses. The second one that there are not enough buses for comfortable transportation, and government are between them in that discussion. Before preparing some solution, it should be researched and analyzed. The purpose of this study is to find optimal number of buses which should be on the particular route depending on a set of factors. So let's look through the main stages of this research. The first stage of the research is to obtain data to analyze. In that case, there was made and taken a set of information about routes in Lviv, addresses of their bus stops, duration, lengths, capacity, etc. Making dataset was based on data taken from EasyWay website and Google Maps. The second stage of the research is to analyze the data which was obtained. Analyzing data contains the following steps. First one, checking data format. Next one, analyzing the distance from city center. Simulating passenger flow based on normal distribution and considering that the distance from each bus stop to city center. Creating diagrams to visualize receiving results for better understanding the current situation. Getting the total duration of particular route and the duration between each bus stop. And the last one is getting the main statistic characteristics of the passenger flow. The next part of research is to simulate the queue of potential passengers on each bus stop. And the next step is to get the number of buses on the route which will provide the maximum number of passengers per one run. All steps which were mentioned above were made with statistical analysis and neural network. But to automate and optimize all the process was used one of the machine learning methods, transfer learning. Transfer learning refers to reusing part of a previously trained neural network and adapting it. Transfer learning was used to adapt old neural network to new, which detects optimal number of buses considering hours and if it's working days or weekends or holidays. Achieved results can be visualized. For instance, there is detecting the optimal number of buses for route number 10 in Lviv. The input data for it is given below. You can see the name of bus station, its number ID, its distance from the city center, and the distance to the next stop. Passenger flow data according to hours and days are displaying right now on your screens. For example, for hours from 6 a.m. till 8 a.m. In work days, the passenger flows counts 185 passengers, and the same time on the weekends it counts 120 passengers. So as you see, it depends. The trained neural network processed with next results for route number 10 in Lviv, which is visualized below. The blue line illustrated the number of buses for workdays and the orange one for weekends. As we can predict, the bigger number of buses should be for these top hours, like from 8 a.m. till 10 a.m. and also approximately from 5 p.m. till 9 p.m. And for weekends is from 1 p.m. till 5 p.m. The best accuracy is 81% due to simulating passenger flow. There is a room for improvements, and to achieve better results, it should take real passenger flow, but not the simulating one. And in conclusion, I can say that the impact of this research is obtaining new relevant data for government to improve transport systems dynamically, changing number of buses, providing maximizing number of passengers for a comfortable trip. Also, obtained data is useful to save fuel costs as empty buses will not ride anymore in 3 hours. References. Thanks for your attention and don't hesitate to bother me if you have questions. My email address you can saw on the first slide of this presentation. Thanks a lot.